You work with glass every day, but have you ever stopped to think about how it's actually made? From a skyscraper's curtain wall to the screen in your hand, it all starts with one absolutely incredible process. So we're going to break down exactly how float glass is made, and this whole explainer is brought to you by our sponsor, Smart Glass USA Corporation. Think about this for a second. A modern float glass manufacturing line is a non-stop marvel. It runs 24 hours a day, 365 days a year, for over 15 years straight without ever shutting down. The scale is it's honestly hard to wrap your head around. So how in the world do they make perfectly flat, totally flawless glass on that kind of scale? Well, it's a crucial question, because before the 1960s, it was a whole different story, super labor-intensive. But the modern float glass method? Oh, it changed everything. And to really get why it's so brilliant, we've got to start at the very beginning, with the recipe. Okay, first up, the recipe for perfection. It all kicks off with a super precise mix of some of the most common materials on Earth. In the industry, they just call this mixture the batch. The star of the show, no surprise here, is sand. It makes up about 60% of the entire mix. But here's the thing, you can't just melt sand on its own. So lime and dolomite are added to make the glass durable and weather-resistant. Then you have soda and sulfate, which act as a flux, lowering the sand's melting point to make the whole process way more efficient. Now, this next part is really clever. The recipe also includes a sustainable ingredient called cullet. And what is it? It's simply recycled glass from the manufacturing process itself. It's the secret to efficiency. It helps the batch melt faster and cuts energy needs by up to 20%. What a brilliant feedback loop, right? So all these raw materials are fed into an absolutely massive furnace and heated to an incredible 2,800 degrees Fahrenheit. The mixture will spend up to 50 hours in there, just melting and refining until it becomes a perfectly homogeneous, totally bubble-free molten liquid.
All right, now we're getting to the heart of the whole operation, the single most critical part of the process, the innovation that gives float glass its name, the tin bath. Seriously, this is where the magic happens.
That molten glass we just made flows right out of the furnace and onto a perfectly calm bath of molten tin. And because the glass is less dense than the tin, it floats right on top. It's the core principle, and it is every bit as elegant as it sounds.
And this is the genius of the whole method. There's no mechanical polishing, no grinding, none of that stuff. Gravity and surface tension literally do all the work. The molten glass just naturally spreads out across that perfectly flat liquid tin, creating a sheet with flawless optical properties and perfectly parallel surfaces. Just like that.
So, you're probably wondering, how do they control the thickness? And the answer is just wonderfully simple. To make thicker glass, they use barriers to confine how much it can spread out. And to make thinner glass, specialized top rollers are sped up, gently stretching the glass ribbon to exactly the dimension they need. Once our ribbon of glass leaves the tin bath, it's technically solid, but it is still incredibly hot. And this next step is absolutely critical. A long, careful cool down to prevent internal stresses that could cause the entire sheet to shatter. This all happens inside something called an annealing layer, which is essentially just a massive controlled cooling chamber. And when I say massive, I mean it. We're talking a journey of over 800 feet. That's nearly the length of 3 football fields.
Over that immense distance, the glass temperature is brought down gradually from about 1,100 degrees Fahrenheit all the way to room temperature. This slow, controlled cooling is the key. It's what removes all the internal stresses, making the final glass sheet incredibly strong and stable.
So after that long cool down, what emerges is a continuous ribbon of perfect glass, ready to be cut and transformed for a huge variety of modern applications. And you have to realize this one fundamental process is the starting point for almost every type of flat glass you encounter. From the windows in our buildings and cars to solar panels and the touchscreen in your pocket, it all begins right here as a simple sheet of float glass. You can think of this whole process as creating the perfect canvas, and it's that perfection that allows innovators, like our sponsors Smart Glass USA Corporation, to take this incredible material and push it even further, developing advanced technologies like switchable privacy glass that can turn a simple sheet from clear to opaque with just the flip of a switch.
So the next time you look through a window, what are you going to see? Will you just see the view on the other side? Or will you now see that incredible journey from a simple grain of sand to a flawless, high-tech marvel of engineering?